Today we're going to look at the desmos slides for 7.2.11. And if you haven't already done 7.2.10, I recommend going back and watching that video first. These desmos slides are going to involve drawing a graph of a proportional relationship when you have one point other than the origin, when you can find a constant of proportionality from the graph, and understand the information given by graphs of proportional relationships that are made up of points or lines. So that sounds like a lot of information, but really it's coming down to just being able to look at a graph and interpret what the graph means. The first slide, other than the target slide, that we should take a look at is what could a graph represent? So what does a graph mean? What is it showing us? So first of all, there's a point on the graph. Here we go. We have that highlighted right there. The point could mean lots of different things, but let's go ahead and let's take a look at the x-coordinate of the graph and then the y-coordinate of the graph. So that's going to give us the point. So if we come all the way over here, this is how far we go along the x, and then all the way up is how far we go along the y. So along the x, we're going 16, and then going up along the y, we're going 12. So we write the point that is right here as the point 16, 12. All right, so when we need to go write in the point on the graph, the coordinates, we're just going to write 16, 12. If you are not sure what goes first, x will always go before the y because x comes first in the alphabet and y comes second in the alphabet. That's how I remember it, so it's easier. Alphabetical order. Now, they are telling us some different things here. We can label our axis whatever you want. Now, they do give us this table that they say can help us. So it says use the table to help you. So I'm going to put here, if I had the point x is 16 and y is 12, could we figure out how many y's there are for one x? This is just our constant of proportionality. So I can take 12 and I could divide it by 16, and that gives us 0.75. So for every 1 of x, there's 0.75y. What is a relationship that could be represented by that? Maybe for every 1 minute you walk, you go 0.75 laps around the track. Or maybe for every 1 hour you work, you get $0.75. That would be really bad, but that could be something, who knows? So you can label your x and y axis whatever you want in the table below. I like for every, maybe it's your time, and your y-axis label could be distance. So there you go. And you can have so many other options. It's just whatever you want. So it could be time or any other creative option you can think of. Okay, so this is just showing you that your graph can represent relationships between an x value and a y value. And we're going to look at some situations that do that will maybe help clear this up. So we're going to start with Tyler. Tyler's going for a little walk at an amusement park. He walks at a steady pace from the ticket booth to the bumper cars. So the point on the graph, 40, 50, you see that point here, is showing us his arrival at the bumper cars. What do the coordinates of the point tell us about the situation? So we're going to look at the graph. Here we have our elapsed time as our x value. And our distance from the ticket booth is our y value. Okay. So the point here tells us that if we've got that, it took Tyler here 40 seconds to go the 50 meters. And let's take a look. So here is my graph. Okay, there's my line. It's a straight line that goes through 0, 0, so we know it's proportional. If we look at the x, that was 40 seconds. And if we go up here, the y was 50 meters. Okay, so let's look at a little chart that kind of shows our distance. When Tyler had not done anything, he had not moved at all. I'm going to erase this a little bit so we can see better. I'm going to take a look at the point. So I have the 0, 0. So I know I just talked about that, but we've got the 0, 0 point there. Then we have this point. At 20 seconds, he went 25 meters. So I've got x is 20, and I'm going to go up to 25. That's the point. 20, 25. Then at 30 seconds, he went 37.75 meters. So if I go 30, 37.75, it's an estimate, but I'm guessing it's about right there. And the last one here, at 40 seconds, we already have that he went 50 meters. Okay, so there's all of my different points. We are being asked something very important here, and it's the concept that we've been talking about over and over again, but now we're going to apply it to a real-world situation. How far does he go each second? So if we want to figure out how far he goes for each second, to find that, we are just going to use our constant of proportionality. Hopefully that word sounds familiar to you. So our constant of proportionality. So to get that, we are going to take any point other than 0, 0. 0, 0 will not give us the information we need. So we're going to take, I think the easiest point is 50 divided by 40, or 5/4. Or we can say 1.25. Either one of those works. So for every 1 second he walks a total of 1.25 meters. Okay, so if we needed to plot all those points and fill out our grid, we have that. Now if we go and we look at our graph, is this point the point, this point from right here where it's 1.25, is that on our graph? And if we look here, here's 5, 1, 1.25 is about right there. So it looks like if we were to draw our line, it would definitely be on our graph. Okay, so let's take a look at and answer this question. Starting off, what does the point 0, 0 mean in our situation? 0, 0 means that it's the starting point. Okay, it is when Tyler has traveled 0 seconds and 0 meters. So it's a starting point where he hasn't traveled anywhere at all yet. So the graph is really nice to see. It can kind of show us visually that we have a proportional relationship because it is that straight line that goes through 0, 0. Now, one thing that we can do with our graph is we could write our equations. So I want to take a look at a table that can be set up with these pictures. So we have our time and our distance. We travel 0 seconds, or at 0 seconds we've gone 0 meters. That one doesn't help us too much. But then we had a couple other parts on our table. We had that for 40 seconds, we traveled 50 meters. And then another very critical point that we talked about, or that we found, was that for every 1 second, we traveled 5/4 meters or 1.25 meters. Now here is the question. What if we have t amount of seconds? How many meters are we going to travel? So each time we have our constant of proportionality. So here's our constant of proportionality. It's 5/4. So that means we are going to take our time and multiply our time by 5/4. Now I'm keeping it as a fraction for a reason, because the fraction is going to be really easy to flip when we go the other way. So if we have our distance is equal to 5/4 t here, we can set up our equation. Distance equals 5/4 t. So from our graph and our chart, we can get our constant of proportionality just like we did before. And then from there, write the equation. So we just saw 3 different representations of the same relationship. We have the graph, which was on the previous slide, our chart, which was also on the previous slide, but I recreated some of it here, and now the equation that represents that. And then if we get really fancy, we can flip our equation. So if we had here distance equals 5/4 t, and I wanted to switch my time and my distance and figure out how long it takes me to go a certain distance, what we do is we flip the 5/4. Remember that if we if we switch the variables, we flip the fraction. So there are our 2 equations that we can use to represent the situation. Personally, I think writing the equations is the hardest part of what we do with proportions, so it can get kind of tricky. The trick is to write your t and then what your constant of proportionality is multiplied by that t, and that will kind of help us start with at least the first equation. Getting that second equation is a beyond level thing, but I think you can all do it because you just switch the variables, flip the fraction. All right, I think we are ready to move on to the next slide. Okay, that is it for Tyler. We're not going to talk too much about Tyler today, but we will talk about Tyler next time. We're going to move on to seagulls. What seagulls eat? This is disgusting, but we're going to set up this proportion that 4 seagulls ate 10 pounds of garbage. Assume this information describes a proportional relationship. Let's plot a point that shows the number of seagulls and the amount of garbage they ate. Okay, now, if we had 0 seagulls, think about how much garbage they would eat. If there's 0 seagulls, that means they are eating 0 pounds of garbage. That's a really weird situation, but it's what we're at now. Okay. The other relationship they give us is that if we have 4 seagulls, they're going to eat 10 pounds of garbage. One thing I'm going to do is I'm going to take a peek at what my x variable is. So we have here x is the number of seagulls, and what my y variable is, which is the pounds of garbage. So when I'm reading about this 4 seagulls and they ate 10 pounds of garbage, my x variable is the number of seagulls, and my y variable is the pounds of garbage. So that's our y. So that means we're going to have the point 4 for x, 10 for y. So we're going to go and plot that point for 10. We're going to go over 4 up to 10. And we're going to use the line tool on Desmos. Your line tool is way more efficient than my line tool, but I am going to still draw a line tool. I'm going to connect my 2 points. I'm going to start 0, 0, go up there, and there is my line. All right, so now I have my graph. I plot the points that shows the number of seagulls, and we've got our 0, 0 here. So that's a line, that's a relationship. So that's one way to represent the relationship. We have 2 other ways that we can represent the relationship. We can also set our relationship up as a chart where we have 4 to 10. Or we can have something like the number of seagulls times our constant is equal to the amount of garbage they eat. So let's see. We're going to say the garbage is equal to whatever our constant of proportionality is times the number of seagulls. So we can set up an equation or a chart, or we even have the graph. I like the chart. It's going to kind of help us. I'm going to use S for the number of seagulls and G for the pounds of garbage. Okay, that information hopefully will set us up for the next slide. So let's go ahead and go to the next slide. Okay, so we have our graph recreated on the next slide. I hope that carried over for you. It should have. But if we have 4 seagulls that ate 10 pounds of garbage, and I drew my line. Now, the first thing that this problem is going to ask us to do is to plot the point 1, K on the line. So I'm going to plot this point on my line here in green because it's going to show up really well in that black line. So I have the point 1, K. So if I go over to 1, right there, that big circle there that I drew, that is about my point on there. And we're trying to figure out, what is this value here? What is it? Okay, we know it's 1, but we're not sure what the y value is. What that is going to represent to us is something very important. It is our constant of proportionality. Okay, so what we're going to look at is how we figure this one out. So I'm going to use a little table to figure this out. There's nowhere on your Desmos to try this, but if we have 4 seagulls for 10, how much do we have for 1? Well, we just simply take the second column and divide the first column, and we get 10 over 4, 5 over 2, or 2.5. Okay, so that is 2.5. So the value of K that they're asking us is 2.5. The value of K in this context, so this 2.5, represents the y value. Now that doesn't help us too much though. So 2.5 represents the y value, which is how many pounds of garbage one seagull eats. It's our unit rate, okay, or our constant of proportionality, and it is how much for one of something. Okay, so that 2.5 represents how many pounds of garbage one seagull eats. Every single proportional relationship, we can find what the y value is when x is 1, and that will be our constant of proportionality. It's very tricky. I'll say it one more time. Every single graph that we do, we can find the x value of 1 and what the y value will be. And that y value is our constant of proportionality. It is what we are multiplying everything by each time. The reason that is really good to know is because then we know our unit rate, and we can write an equation with that unit rate. So when it asks, write an equation that relates the number of seagulls, which is our x, to our pounds of garbage, which is y, well, we already know our unit rate. We're going to take our y is equal to whatever our unit rate is times however many seagulls we have. And that is our unit rate. It's a pretty tricky concept. So what this comes down to are two main ideas that we need to remember. First, we can interpret points on the graph in terms of the context it represents. So I'm just going to write down a little notes for us here. We need to know what the x values are, what the y values are, and how they relate. And we do that by finding the unit rate, which we can divide the y by the x, and that gives us our point at 1. So it's kind of neat. So that's the first thing, is interpreting points on the graph in terms of what the context is. Then the second thing, the y value that goes with the x value of 1 is special because it shows us the value of the constant of proportionality. I can talk, I promise. So the y value that goes with the x value of 1 is special because it shows us the value of the constant of proportionality. It can be seen using the table or a graph. And actually, it can also be seen if we have an equation. It's the value that's on the x. So really quick, just to bring this all together, if we have a graph, and I'm just going to talk about Tyler here. He had the point where he walked for 40 seconds and he went 50 meters. We also had the point on that graph that was 1,5. So that kind of showed our constant of proportionality there. We can also represent that relationship in a table where we had his time and his distance, where we had the point 40, 50, 1, 5/4, and we also took a look at if we had the time, it was 5/4 times the time, and that can also be represented as an equation. Our distance is equal to 5/4 times whatever time it is. So all three of these relationships relate together and they mean the same thing. It's just in one way, maybe better in different situations, so we have all three ways to represent. Okay, last thing that I want you to do is just evaluate how well you feel like you know this information. So, do you feel like you can draw the graph of a proportional relationship if you were given a single point? So that was like if we had the point 40, 50. Can you put that on the graph and then sketch that line? Can you find the constant of proportionality? That's just taking our y over x and finding out what that is when x is 1. What is the y value? Then I can understand information given by graphs of a proportional relationship that are made up of points on a line. So can you see what all the different points on the line are? Okay, So your big takeaway today, I would say, is just making sure you know how to find the constant of proportionality from a table or from a graph, okay, or even looking at an equation. So that is it for section 11. It's a nice short little section, but it is pretty tricky. If you do have any questions, feel free to jot them down and make sure you ask them when I come back on Wednesday. All right, good luck.